Okay, so for the final chapters on surface integral, okay, so for this chapters will be divided by 4 parts. Okay, so let's move to the first part on surface integral of scalar field. Okay, so in the previous chapter we learned on line integral. Okay, so we are dealing with line. Okay, with line. Okay, but now when we are talking about surface integral, so we can imagine like we have a surface on a 3D plane. Okay, so technically we'll use the idea of on the first chapter, okay, which involve with the graph sketching. Okay, so we will also include the knowledge on double integral that will be used for this chapter. Okay, so suppose that we have a surface here, okay, and then the surface integral of a scalar field, okay, is denoted by this one. Okay, so if you notice that we have ds, but when we are talking about double integral, so we should have dA. Okay, so how can we convert from ds to dA actually? Okay, so so actually based on the figures based on the figures in the previous pages, so actually the changes of s, since ds is talking about the changes of s, okay, can be it can be equal with this one. Okay, where n is actually unit normal in outward direction to the surface, and then k is also a unit vector here. Okay, so eventually, okay, so ds can be changed with can be changed into dA by using this relation. Okay, so from here, okay, so from here, since we are dealing with 3D 3D space, okay, so like what we had in the multiple integral, we have either the projection on xy plane, yz plane, or and on xz plane. Okay, so we have 3 types. Okay, so let's see the first one, when the projection. Okay, I would say that the projection means that the shadow of the surface, okay, whether the shadow is on which plane. Okay, so let's talk when you have the projection on xy plane. Okay, so we have the equation of the surface is given by this one. Okay, so let's see here. So we will write as z is equal to a function of x and y. Okay, so obviously that we have learned in the first chapter. Okay, so we will give you the equation of the surface, okay, so that you will be able to sketch. So you will use that equation actually to solve for surface integral. Okay, and then you have learned also about unit normal to a surface in the vector value function topics. Okay, so the unit normal vector is defined by this one. Okay, okay, so from the in the previous slide, we have that the change of a divided by n dot k, the magnitude of n dot k here. Okay, so it's actually the change of s. The change of s is equal to this one. Okay, so we are now, since to be able to solve surface integral, we're going to use the idea of double integral. So obviously that we need to change in dA. So from here we change as dA here. But what about this part? Okay, so for this part is actually from here. Okay, so this one is actually come from this one. How can you get negative fx actually when you have z equal to a function of x and y? So if we rearrange, we're going to get z minus a function of x and y equal to 0 here. You have to be able to write in this form so that you will be able to solve for surface integral actually. Okay, so from here, that's why you got negative fx and negative fy is actually from here. Okay, and then if we apply dot product, so this is the remaining term for the magnitude for n dot k here. Okay, so since here our ds actually is equal to this one, or change of a divided by n dot k, so since we have this part as this one, so we can rewrite as in this form. Okay, so that is the idea actually. So you have to know the formula on how can you change from ds to dA is actually equal to here. Okay, so this is the scalar function that will be given to you in order to solve for the question. Okay, so you know that this one is come from this one. Okay, so we let that phi is actually equal to z minus function of x y equal to 0 here. Okay, so you have to be able to understand the concept on how can you change ds to dA. Okay, so eventually this one we are talking about the projection on xy plane. In the simplest analogy is when you have the shadow of the given surface is on xy plane. Okay, or be changed. Okay, this one will be changed based on the projection on which plane. That will be explained later on. Okay, so let's see from here. And then one more thing, if the question asks you to calculate the surface area of the surface, you can just applying means that this scalar function will be equal to 1, so that you will have a surface area of that surface. Okay, so you have two things that you have to remember actually, okay, when the question asks for surface integral and also for surface area of the given surface. Okay, so let's see for the first example, the question asks you to evaluate the given surface integral where sigma or the surface is a portion of the plane x plus y plus z equal to 1 that lies in the first octane. Okay, so the first step that you have to perform is actually to be able to sketch in the correct position, and also what should I say, you have to be able to identify the projection first. Okay, so let's see for the first one. They talk about the first plane, the plane that lies in the first octane. Okay, so if you sketch, actually you will get like this set. So eventually you will get like this. Okay, so it's a plane. Okay, so this is the plane for x plus y plus z equal to 1. Okay, based on the given equation for the surface. Okay, so you will see that actually we have the projection on this plane. Okay, so this plane is on xy plane. So if we like to take into 2D graph, so eventually you will have like this. Okay, you have to be able to sketch sorry, this one should be 1, this one should be 1 here, this one is y. Okay, so this is the projection on xy plane. Okay, so this one is actually y equal to 1 minus x here. Okay, you have to be able to identify the projection so that you will be able to find the limit, because you are talking about dA. Okay, obviously that dA, when you are dealing with the projection on xy plane, you have to know the limits. Okay, so the basic idea is to refresh back on whatever that you have learned on multiple integral. Okay, so from here you have to get the phi function. Okay, so from here x plus y, sorry, this one should be sorry, we have x plus y plus z is equal to 1. Okay, so the idea is actually we know that z is equal to function of x and y here. Okay, so if we take make z as a subject, so eventually you will get that z is equal to 1 minus x minus y here. Okay, so you will have that fx equal to -1 and then fy is equal to -1. Okay, since we need to find our ds is equal to the magnitude of grad phi time with dA here. So eventually you will find the grad phi from here. Okay, the magnitude for grad phi. Okay, so this one is equal to phi, right? Okay, so from here we know that the magnitude for grad phi is equal to square root -1 square plus, sorry, let me see again, this one. Oh, sorry, I forgot to mention about this one. Okay, so you have to remember that actually grad phi is actually come from this one. Okay, fx square plus fy square plus 1 actually here. Okay, so okay, wait, yeah, why you got 1 is actually if you differentiate, because we get phi is equal to z minus a function of x and y, right? Z minus function of x and y. Okay, so from here you will get that if you differentiate respect to z, you got 1, so that's why we have 1 here. Okay, so don't forget this one, it should be -1 squared plus 1 here. Okay, so eventually you will get here as square root 3 dA. square root 3 dA. So let me clean this one first. Okay, so from here is actually square root 3 dA. Okay, so if we manage to get ds, so we can get into what should I say, into the original question. So original question give you like this, right? 6xy ds. So we know that this is the given what should I say, the given scalar function. Okay, so if you change this one, you will get that actually 6xy. So ds now is equal to this one, and then this one is equal to square root 3 dA here. Okay, so let's take out all the constant. You'll get 6 square root of 3 xy dA. Okay, so now when we are dealing with dA, means that is there's two possibilities, whether dy dx or dx dy. Okay, so the idea is actually to get the limit from here, from this sketch. Okay, that's why you have to get the correct region from the given surface. Okay, so from here, in my cases is I would like to change dA into dy dx, let's say. Okay, you can also change to dx dy. It's possible because it's just a simple rectangle, what should I say, rectangular, right? And then here the limit you should get a 0 up to 1 here, 0 1 minus x here. Okay, so if you manage to get up to this point, I believe that you don't have any problems because we already learned about this one. Okay, so the final answer that you should get after you perform double integral from here, since you already successfully get the correct limit, the final answer should be square root 3 divided by 4 here. Okay, and then one more thing that I have to highlight is since we are talking about dA, so we learn about polar and also Cartesian. Okay, so whenever you are dealing with circular shape on xy plane, okay, so means that you are able to solve in polar coordinates too. Okay, because dA can also be changed into r dr d theta, right? Okay, so if you see from example 2, okay, so obviously that it will involve with circular type projection on xy plane. Okay, so I would like you to try by your own. Okay, I have give you the final answer here. Okay, so I would like you to try by your own. Okay, okay, same goes to this one. Okay, so you can try by your own also. Okay, we'll discuss during our live session. Okay, so now previously we are talking about the projection on xy plane. Okay, so what if we have or we can say that we cannot project the surface on xy plane? Okay, because in a certain condition, when we have a surface, I mean the given surface equation, okay, does not give you the projection on xy plane. Okay, so therefore we need to consider that the projection on other planes, which is either on yz plane or xz plane. Okay, so here if the projection is on xz plane, okay, so now the changes is actually on this one. Okay, so we have fx and fz. Okay, so the idea is still similar, but then the changes is on the magnitude for grad phi actually. Okay, and also based on your scalar, based on the given scalar function also. Okay, so that is the second type. Okay, and then the third type, when you have the projection on yz plane. Okay, so since we are talking about the yz plane, obviously that your dA is actually is on either dy dz or dz dy. Okay, don't be confused. Okay, the idea is similar on xy plane, but then we just change the, what should I say, they exist now. Okay, so here the magnitude of grad phi should be changed into this one. Okay, so I have prepared one example here. If you see here, is the given surface is talk about the portion of the cylinder. Okay, so if you like to try to sketch for this one, actually we will have x, y, and then z. Okay, so eventually we will have cylinder like this. Sorry for my wet sketching. Okay, so this one is z equal to 0, and then this one is for z equal to 1. So eventually you will have a cylinder. Okay, but then when we are talking about the projection or the shadow, okay, so eventually you cannot see the shadow. You can only see what should I say for this one? You will only see like this. Okay, it's I mean, if you see from the from the top, okay, from the top, okay, so you will only see like this if we take the projection on xy plane. Okay, so you only seen the projection on the z equal to 1, but you cannot see the shadow on z equal to 0. Okay, it should reflect to whatever planes that give to your question. I mean, okay, so here the shadow only involved for z equal to 1. What about z equal to 0? Okay, so that's why you have to change the projection. Okay, so the simplest idea to see is actually if you see from yz plane. Okay, I mean, if just now if you see from the top, I mean from the top of z axis, you will see like this. But then if you see from the right side or right or left side of this plane, you will eventually get like this. Y, and this one is z. Okay, so this one will be 1, this one will be negative 1. Okay, so now is actually when you see from yz plane. Okay, so I'll let you try. I give you the idea on how actually the projection will be changed based on the question. Okay, so I'll let you to try by your own whether you can actually get the answer or not. Okay, so that's why it's very important for you to be able to sketch, or I would say that to be able to imagine the surface given in the question. Okay, so that's all for this video. Thank you.